This is TWIS. This Week in Science, episode number 743, recorded on Wednesday, October 16th, 2019. Science on the brain. Isn't it always? I'm Dr. Kiki, and today I'm going to fill your head with whispering whales, cool dinosaurs, and brain space. But first,
TWIS is supported by listeners like you. We thank you for your support. We really couldn't do it without you.
Disclaimer, disclaimer, disclaimer. The world is not always as it appears to be. But more often than not, it's exactly as it appears. The rain falls down from the sky like rain, and the sun shines with the brightness of the sun. The fog was as thick as fog. Sometimes putting all your eggs in one basket is just an efficient way of collecting eggs. While not every wasteland is vast, there are some modest wastelands out there. A rose can be as red as a rose, wherever red roses are found. Still, there are some places in the world where you can find things as they are and still be full of surprises. The world of dumpster diving, or keeping with the theme of the show, the world of science. Finding the world as it is, describing it as you find it, without analogy, simile, or cliche exaggeration, can be more inspiring than a poetic interpretation of unicorns and heat. Science is the art of revealing a thing as it is. And in the spirit of such things, we bring you a show about this week's science news that we call This Week in Science. Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
and a good science to you too, Justin, Blair, and everyone out there. Welcome to another episode of This Week in Science. We're back again to talk about science, all the fun stuff that was in the news for the last week. Oh my goodness, and there was a bunch of brain news. So our show is packed to the gills, no, to the skulls with brains.
Back to the skull, interior skull wall.
That's right. I have stories this week about some good energy. I'm bringing this show some good energy, man. I've got the cool dinosaurs that were mentioned just a couple seconds ago, and brain news. Go figure. Justin, what'd you bring?
I've got Neanderthals of the Aegean Sea, case for brain space, unnerving concussions, and aerobic activity for obese longevity.
Very good. And moving into the animal corner, Blair, what is there?
I have ancient mammals, and I have whispering whales, and I have very, very smart pigs.
Do you have a whole farm full of very smart pigs, or is this
If only.
Oh, Blair on the farm? It's like her idea of heaven.
Pigs are great. Guys.
Pigs are
Just
great.
Wait until we get into the corner, but honestly, pigs are great.
All right, let's get into the show. I want to remind everyone, if you are not subscribed to This Week in Science online, you can find us as a podcast, all the great podcast portals that there are: iTunes, Google, wherever, Spotify, Pandora, radio.com, TuneIn, wherever. You can find us there. We're also on YouTube and we're on Facebook. Look for This Week in Science, or just visit twis.org for information. And at twis.org, it's also where you can find a link to pre-order our 2020 Blair's Animal Corner annual calendar. It's available right now, so get in there. Go to twis.org and pre-order yourself a calendar, or one for your friends. The holidays are coming up. Okay, you guys ready for some good energy?
Yes.
Let's go to get some good energy. Yes, I was looking through the news this week, and there were a couple of stories that caught my eye because they were just kind of that happy vibe. There's bad vibes all the time when we're thinking about climate and where things are going. But this week, there are 2 articles on Ars Technica that report really good news in the energy efficiency front and renewable energies. So, wind farms are finally coming to the fore in the United Kingdom. And according to a new analysis, the group called Carbon Brief, they have determined that this summer, wind production, that this renewable generation of energy surpassed fossil fuels for the first time in the United Kingdom. So because of wind energy coming online, they estimated that renewables produced 29.5 terawatt hours of energy in July, August, and September. Fossil fuels only produced 29.1 terawatt hours. And carbon emissions were even better, with the UK starting to drive down coal-fired generation, which is leading to a decrease in its emissions of those carbon emissions, right?
Nice.
Less coal, less carbon, less pollution, more renewables, and there's more wind generation and wave generation coming online in the UK in the near future. 12 megawatt turbines are now being produced in Europe. So each wind tower can produce more energy. And the wave power is a big deal. Here in the United States, we want to, come closer to home to where our podcast is being produced. Here in the United States, a report is out, a new paper is out that the United States green economy growth is just completely outpacing the fossil fuel industry, even without the subsidies that the fossil fuel industry gets. The study estimates that revenue in the global green economy was $7.87 trillion in 2016. At $1.3 trillion, the U.S. made up 16.5% of the global market. And that in the green energy economy, the supply chains and the number of people employed in these areas, the green economy is employing nearly 10 times more people than the fossil fuel industry at this point. It's almost 10 million to 1, which is very exciting. The energy policy that has been put forward by Trump was going to bring fossil fuels into the fore, but it seems as though even without that plan and with sustainable investments and the growth of renewable energy and also the reduction of coal energy here in the United States as well, we're starting to really ramp up. In 2017, China emerged as a global leader. It has plans to invest $361 billion in clean energy by 2020 to generate 13 million jobs. A lot of news is coming out about China and the work they're doing, as they're another massive emitter on the global scale. And there are a lot of other countries that are currently gnawing at the bit to overtake the United States as green economies and as producing clean energy. Unless, of course, things like the Green New Deal get more traction. But we will see where that goes and what ends up happening.
So as I'm currently broadcasting from Denmark, I think I should probably point out Denmark has more than 40% of its electricity comes from wind.
Is Denmark very windy?
It actually can be pretty windy. It's but one of the interesting things is you'll see these sort of giant wind turbines. There's a gorgeous array of them out sort of at sea in the North Sea, but you'll sort of see them pop up in strange places. I was at a mega IKEA store a couple days ago.
That's very fun.
Giant wind
You
turbine
just got back, right? It was 2 days ago. You just
it really kind of was. It was like you go in, you have like the 3 things, and then it's a half a day later. And you're still wandering around, piling things in. Like, I don't know how to get out, but I need this lamp. Right? But they had a big wind turbine with an IKEA logo on it. And I was kind of wondering if they had sponsored it in some way, or if it's because it's on their property. They got to put. No, that giant wind turbine is powering this giant IKEA store. And so there's not just a sort of governmental push to do these sort of things, but it's being taken up by industry and companies saying, yeah, we're going to build this giant mega store. Let's keep it off the grid. So it is a thing that really, and it's economical. And like you pointing out, the whole idea with coal jobs has been a misnomer for decades, because it was automation that eliminated those jobs. It has less to do with the energy shift. And there's much more jobs available in the green economy than there are.
And it's growing.
And it's growing. It's
And
only
it's
going
growing.
to grow. Yeah.
Well, and this is what we want, right? We want the right choice to be the easy choice. It took some early adopters to do a lot of extra work, to pay more, to struggle to find infrastructure, to do what needed to be done to make things more efficient, more acceptable, more available. But it's getting to that point now where the scale is tipping, and green energy is the wise choice from all angles, which is ultimately what we want.
Yeah, let's keep it going. And I hope that we'll be able to report on all sorts of new advances moving forward in turbines and photovoltaics and batteries and all of these technologies that chemical and mechanical advancements are going to allow them to become more and more efficient and better at producing that energy for us. Now let's talk about super efficient. What's super efficient? The human brain.
Of course.
The human brain is super efficient. But there's this weird thing about humans. We mature when we're young. We mature really slowly. It takes a long time for this peak efficiency organ to get to the point where it's actually doing the stuff that we recognize with, people stuff, right? The cognitive work of being a person. Takes a long time to get there. And so there are these questions about what are the differences in the human brain versus our closest relatives, say, not exactly closest, but chimpanzees, some of the closest animals to us on the planet. What are the differences in our development versus theirs? Because chimpanzees, they do develop more quickly. They kind of have to. But this is something. When did it happen in human history, and why did we suddenly have this long developmental period? So researchers publishing this week in Nature have been working with brain organoids, and now these organoids are little collections of stem cells that have been allowed to grow and turn into a very mini tiny version of a brain. It's not an entire brain, but it's got multiple cell types. It's got multiple layers. I just kind of imagine them as cute little brains in a dish.
I'm imagining, those gummy fake hamburgers, a little gummy brain.
There we go. It's not exactly, neither of us have the exact description of what they look like, but these mini brains, as they are nicknamed, allow researchers to grow something that approximates the real organ without actually having to grow a whole brain, or for that matter, a whole individual. And so they made these cerebral organoids from chimpanzees and humans, and then compared the genetic signature over the developmental period to figure out what exactly was going on that was different. And they did find that there's no difference in the organoids in how they look between the chimpanzees and the humans. But the genes behave completely differently, and the behavior of the genes changes over time. And the chimpanzee organoids, they say, grew up more quickly than the human organoids. So even in a dish, the chimpanzee little mini brains were getting older faster. Taken at the same time point, samples of the cells, these neurons, chimpanzee neurons were more mature than the human neurons, and they had a profile of their gene behavior that is what you would recognize later on in older human brain cells.
Interesting.
And so there's a lag that happens in human brain neuron development. They really are not aging as quickly. the genes that are turning on to create changes that lead to those structural and functional changes that occur that allow cognitive thought they're happening at different phases of time. So compared to each other, these timelines are very different, and they may explain a lot. And beyond the actual timing differences, they found that there were differences in the DNA for sure. Some stretches of DNA are not present in humans that are still present in chimpanzees and other primates. And those stretches of DNA seemed to be influential over the behavior of other genes. And so these were kind of control centers that maybe are activating some of those genes early. And since humans don't have it, they don't get turned on as quickly. So what happened maybe so that humans lost it? And why was that adaptive is a big question. So these little mini brains, they're telling us a little bit. They haven't told us everything yet, but we're learning that there are these similarities, there are these differences, and maybe eventually peering into them a little bit more will tell us more about our evolutionary history. How we got to be human.
I love the idea that we gained this superior intelligence by being slow.
Yeah.
Yeah. It takes us a
down.
while longer than the rest of you apes. But when we get where we're heading, then it's fantastic.
Yeah.
Are we sure that we're slower and not that chimpanzees evolved to develop faster? Because we're looking at these two ends of a forked road. We're not looking at a common ancestor.
Yeah, but
Right.
if you leave the common ancestor, and this is a direct comparison, and you look towards the rest of the animal kingdom, that's sort of the thing with animals, is the young develop very quickly so that they can go fend for themselves.
In some cases, not in all cases.
Well, in most cases, come on now.
There's altricial and precocial young. Those are two completely different strategies of development. And one is an animal that's ready to go, and one is an animal that needs coddling. And if you look at an animal like most rodents or even an opossum, when they only live a very short amount of time, if you look at the amount of time they're dependent on their mother, it's actually a huge percentage of their lifespan.
That's interesting way of looking at it.
Yeah, but chimpanzees, even though they're dependent on their mother, very similar to humans, it's for less time. So everything
I
is.
can't picture any animal in the wild that has 12-year-olds toddling around behind.
Well, an 8-year-old gorilla is pretty similar to an 8-year-old human.
Oh.
Yeah.
Very playful, not good at reading the room.
Not good at reading. No.
So there's definitely there's certain relationships that are similar, but at a certain point, at least with gorillas, as my example here, I'll follow it through. There's a moment when it kicks into high gear way before it would for humans. That being said, gorillas don't live nearly as long as humans.
Right.
So if you're looking at it, is it that they speed up all of a sudden, or is it proportional to their length? Their
relative to
lifespan.
There is some interesting questions there. Yeah. But anyway, we're getting at these gene regulatory features that are really unique to humans and differentiate us from the other ape groups, which is pretty cool. Tell us more about ourselves. Justin, I was going to move on to the next story.
I just had a thought though that it'd be a trade-off. If we could slow down that cognitive development, could we extend our life times? Could that lend itself to longevity? Is
this why more people are living at home with their parents longer now?
So they will live to be 120.
Well, I'm going to go ahead as the person who wants to live forever on the show and say, not worth it. Yeah. I was dumb long enough. I cannot wait to be an adult and have more knowledge and be a functioning human.
I don't know, Blair.
Functioning humans. This has nothing to do with functioning humans. The Aegean Sea is the most storied sea, I would say, of them all. And as far as seas go, it's probably one of the most beautiful seas that you could ever view. And in the Sea of Stories, that there are picturesque islands with white sand beaches and clear azure waters that you can see down to the bottoms of. It's just kind of gorgeous. There is amongst these an island that mythology might attribute to the birthplace of a god, the island of Naxos. The child Zeus is rumored to have run barefoot through the caves along the beaches here. So it's the ideal scene, iconic everything ancient Greeks held sacred in this spot. And it turns out that while the history of how the Greeks came to inhabit the islands between sort of Turkey and eventually Greece is maybe even more interesting than the mythologies that they came up with later, they weren't the first to settle there, apparently. Not by a long shot. In fact, an international research team led by scientists from McMaster University has unearthed evidence that the island of Naxos, which in the Aegean Sea, you got Greece over somewhere, and then as you make your way towards Turkey, there's a whole bunch of islands. This is sort of closer to Turkey than it is actually Greece. And they found that Naxos was inhabited by Neanderthals and earlier humans, and inhabited back over the last 200,000 years. Somewhat stunning find. Findings are published in Science Advances, and they've gone through years of excavations. They're finding, what was that? Hundreds of thousands of tools, stone tools, hunting weapons. This is not just there were some Neanderthals or early humans that stopped by and then moved on. This was inhabited for quite some time to have amassed this number of tools. The authors are suggesting that the Aegean basin was perhaps more accessible than earlier believed. One of the beliefs has been that this stretch, because these are islands, the only way that they could have been populated is by somewhat modern humans. The number is usually back around 9,000 years for these islands. Range for these islands to be populated, because what was required to get to these islands?
Boats.
You had to have seacraft and able to get out. These were not walkable or swimmable islands. You needed, so two possible theories. One is that during an ice age, there could have been a lot more islands accessible by foot than previously thought, which also brings up an interesting thing. One of the oldest sites of somewhat modern human, at least, evidence is Morocco, the north coast of Africa, is some of the oldest and most recent technologies in stone tool development. Modern humans were finding lots and lots there. This is the sort of the neighborhood. So if it was walkable, or as they're pointing out, perhaps boats were developed much earlier, and perhaps even Neanderthals 200,000 years ago might still have required some sort of seagoing craft, be it a raft, a log to float on, or a very ornately built boat. We have no idea, because unfortunately, one of the things that's really hard to preserve in the archaeological record in the Mediterranean is wood. It's too warm. So we find sometimes we'll find an ancient Viking boat or something like this in Ireland, where the sea is very cold and perhaps the deterioration is rapid. But in the Aegean, wood doesn't hold up too well. So we have hundreds of thousands of stone tools, 200,000 years of habitation on just this one little island, and sort of rewriting one of the out of Africa passages, because this opens up not just the sort of land bridges that we are used to considering of humans, but actually that humans may have taken to the sea. And Neanderthals as well. Although with the Neanderthals, they may have actually been coming back down towards Africa.
That's so fascinating because, we just think of the land bridges and the walking, but the idea that early humans could have been fashioning some kind of, I don't know, boat structures, lashing logs together in some way. Like this is, wow. If we could actually have some record of that, that'd be pretty amazing.
And so this is Neanderthals 200,000 years ago. Neanderthals 800 to a million years in Europe, spreading out across Asia. What's sort of interesting is this would be a almost back to Africa story for Neanderthals getting this close. Yeah. This is, the off the north coast of Africa here. That's awfully close for Neanderthals who had, to become. So then you have to start thinking, is there another braided stream where Neanderthals made it back to Africa at some point? This is so close. Or are we looking at, because we don't have a fossil, right? We just have tools and implements to look at. So, yeah.
Yeah. I wonder how much more time. I mean, we've got evidence that, the Neanderthals, they're down in Spain and humans were mixing. Like we've talked about that just a few months ago. They're down in Spain. Humans and Neanderthals were probably mixing in that region of Southern Europe for a very long time. I mean, that's so close to this area in Greece. It seems as though that there's every possibility that backward flow could have happened, and the genetic diversity that we see, why would it have all happened? Now that we're talking about this kind of movement of people, of individuals through areas, why wouldn't that be represented in the genetic diversity that we have currently?
And it means that we may need some more ancient human DNA to compare with too, because what we've compared with what's Neanderthal DNA and what's modern human DNA is maybe contaminated if there was an even earlier admixture before the later. However, one of the things that I just clicked in, we did a story about an island near Crete that had Neanderthal evidence. That at that point they had determined there's no way you could have swam there, even with the ice ages they believed it was. It wouldn't have even been visible, let alone swimmable. So there's mounting evidence Neanderthals might have had boats or flotation devices of some sort to get from one place to another. They may have been, as we keep finding, more advanced than we allow ourselves to give them credit for. And then really, what's a boat? It's just something that floats.
I mean,
as Wall Street Tech in the as Wall Street Tech in the YouTube chat room calls it, is what's a boat? A great big log.
Yeah, exactly. So there are animals that exist on islands, and the only way we can seem to figure out that they possibly got there was they floated there on a piece of wood. Yeah, they basically just floated. So yes, exactly to that point, it could just be a piece of wood.
Could have happened.
Although I will say though, it wouldn't have been necessarily just accidentally floating there and ending up there. It turns out that like this particular island has the perfect sort of rocks for making stone tools. So if you were an ancient stone tool making society, you would come to this island and go, "Oh my gosh, we have a plethora of resources. We don't have to go foraging for the right stone tool. They're everywhere. We have everything we need to have a society."
Well, I mean, like they could go with a purpose, but just use a log and then paddle. Then you're basically just surfing, right? You're like paddling out into the surf. There could be ancient surfers that got, used their.
Yeah. I think I would, because they could at least they had the stone tools. I like the idea that they were crafting at the very minimum surfboards.
Yeah.
Very minimum. Very minimum.
I mean, what other conclusion could you draw?
I don't know. Surfboards. All right. Maybe not the take-home message that listeners should take home. Yeah. Moving on. Is it time to move into Blair's Animal Corner?
With Blair?
She loves our creatures, great and small. Biped, millipede, no pet at all. You want to hear about animals? She's your girl. Except for giant pandas and squirrels.
What you got, Blair?
Oh my goodness, this seems very apropos based on our previous conversation we just had. So I am going to have to tell you about the first ever observation of pigs using tools.
What?
Yes, which if a Neanderthal can make a boat, a pig can perhaps make a shovel. So this was a accidental discovery looking at a zoo in Paris. A researcher happened to see a pig using a stick to dig a pit. Now, when I first tell you that, and when I first read it, you might be picturing just a pig kind of pushing a stick around, and that could be an accident. It could be them playing, but no. I'm hoping that Kiki will play this video in a second. You can actually see the pig pick up the stick with their mouth and shovel with it. It is very clearly them using this tool. So they saw this, they thought it was a fluke, right? But then they started to test in other spaces. They appeared to be digging a nest to house their offspring. Over the course of 3 years, they observed 11 instances of the pigs using tools. All but one individual were female. They also gave the pigs spatulas to see if they'd use a different type of tool. Those were used twice, but overall, they really just wanted to use the sticks. That's what they were used to. They say it's not clear why the pigs were using these tools because, as far as the researchers could tell, it didn't seem to give them an advantage in digging the pits. I would say, based on what I saw in the video, based on very little, but just based on what I know about animals, I would say if I was a pig, I would want to use the tool so I didn't get dirt up my nose.
That would be beneficial. Yeah.
Yes. So that's my theory. But so this was totally an accident, only observed in captive pigs. So there's all these asterisks. There's only 11 instances over 3 years. But once again, it's time to mention, okay, crows use tools. We talk about it all the time. Otters use tools to crack open food. Elephants move rocks and logs to cover watering holes. We've talked on the show about bats using particular types of grass to amplify their calls. I'm not surprised to hear that pigs, as a very intelligent animal, might use a tool.
I'm not surprised either. I think I am surprised. What I do find interesting is that the spatulas were really not made use of.
Yeah.
But maybe they were a less efficient tool. Maybe they weren't as good.
Right.
Maybe they'd like, oh, I'll try it. No, that didn't work. These people don't know what they're trying to offer us.
Well, and we don't know if they modeled using it for that before they handed it to them, because this might be something that's passed amongst individuals. And so if they don't see somebody doing that, they might not know to use it for that. So there's lots going on. I feel like further study is needed. But
yeah, I'd love to know if it is the kind of thing where, say, like ducks and geese, they have they have instinctual behavior to reach out, and at the nest they'll bring an egg in back to the nest if an egg has rolled out of the nest, right? But if that egg is not an egg, just a square white object, the goose will try and pull that back into the nest. It doesn't differentiate whether or not it's an egg or not an egg. It just has this action to bring the thing back to the nest that it thinks it has lost. And if this is part of their nest building behavior in these pigs, is there some kind of instinctual behavior in the construction of that nest? How are the nests built? What are the features of the nest that become important to the pigs?
Right.
There are a lot of variables maybe at play that haven't even been looked at.
Absolutely. Yeah. I mean, this is definitely the tip of the iceberg, but pigs are smart, and further study. The next study I want to mention here is from University of Chicago, and it's interesting. I would love to get Kiki and Justin your thoughts on this. This is looking at the history of mammals and their habits of being awake during the day or at night. We are, of course, diurnal. We are awake during the day in most cases. But this is actually the exception as opposed to the rule in mammals. Most mammals, if you look around, are nocturnal. And we all have some common ancestors that were nocturnal. Around 250 to 230 million years ago, the mammalian ancestors called therapsids became exclusively nocturnal and stayed nocturnal until the dinosaurs disappeared around 66 million years ago. So you could say that humans are a species that have reverted back to living in the day, as opposed to that being the status quo. Now, the traditional argument, which would make sense based on the timing of all this, is that they were nocturnal to hide from all of the predatory dinosaurs, so that their schedule didn't sync up, so that it was easier for them to hide and then forage during the nighttime when there were less dinosaurs out and about. And then once all of the dinosaurs were gone, they were able to come out into the light. But this new paper, Obligatory Nocturnalism in Triassic Archaic Mammals, Preservation of Sperm Quality, ? Has another idea. Yes. So therapsids were becoming rapidly endothermic. They were being able to control their own body temperature internally. And that's through a metabolism, right? And so that means that over this period of time, their internal resting body temperature was going up. And as they got smaller in the Triassic, you started to see their body temperature going higher and higher and higher, up to around 93 degrees Fahrenheit. Still a lot lower than we're used to, but still pretty high compared to an ectothermic animal where their body temperature will take dips and peaks kind of throughout the day.
Mm-hmm.
So because they have this higher body temperature, they would not be able to offload excessive heat generated by being active without losing a bunch of body water by sweating, panting, etc. Right? So they would want to be awake at night so they wouldn't lose all this this water that is, a valuable resource when you're trying to survive. But the other side of this is that archaic mammals did not have scrotums. And the reason that mammals have scrotums is to keep sperm away from this high body temperature, is to keep them from getting too hot and basically going bad. So when sperm is too hot, it messes with the quality. It messes with the proteins kind of in the sperm. It can cause the accumulation of free radicals, all this kind of stuff. So the scrotum is what keeps sperm from being too hot and basically spoiling before it can do its job.
Right.
So if they didn't have that yet, there was no way to keep sperm cool. So if they're having this constant higher internal body temperature and they're awake during the day, this is a big problem. But because they're active at night, they were able to preserve sperm quality more effectively in this kind of transition period. So this is this new theory, is that it has nothing to do with the dinosaurs and hiding from predators. It's all about sperm.
It's all about the sperm.
Yes.
Because they had to cool down.
Uh-huh.
The therapsids had to stay cool and cool their sperm.
Yes. So
And amazingly, that system can adjust itself, self-adjust to keep warm as well. If things get too cold.
Absolutely. Yes.
Pretty brilliant.
Yes. So if you think about it, it really is quite an amazing adaptation to solve this kind of interesting problem. But in the meantime, this new theory is that these animals actually completely changed their lifestyle to preserve sperm.
But right. It's okay, great, but everything would be harder at night. I mean, you're completely nocturnal, so then all of your mating habits, is that at night? Does that make it harder to find a mate? Is that something that is, maybe that's why many of our ancestors decided, they let's be mammals and let's have a scrotum so we can enjoy the day.
Yeah. So we can enjoy the day.
So another big question here is, I mean, this is without any evidence of the actual therapsid sperm. We don't know
Correct.
what temperatures caused it to denature or have issues. We have no clue.
Correct. This is, if you ask me, wild speculation. And I do think it's just, it's often the most obvious answer is the right one when it comes to this sort of thing. And it just does seem like getting eaten by a dinosaur is more of a pressing threat than having some birth defects in your babies because your sperm was too hot. Like, one thing is your evolutionary line is done. You got
Gone.
eaten.
Yeah.
It's over. The other is your sperm's not as effective. So I feel like out of the two, the theory about avoiding dinosaurs and surviving potential predation is making more sense to me. But I like this idea. It doesn't have to be one or the other. There could be
Right.
multiple benefits. So this
Right.
could be a benefit. I'm with that. That makes sense to me.
Sure. I mean, maybe,
mammals were much more diverse than I think we tend to give them credit for in the dinosaur days. So I'm not convinced that we were all nocturnal all the time either. Like, that's
right.
I mean, that's the conventional wisdom, is that the common ancestor, the therapsid ancestor, was nocturnal.
Yeah.
So the understanding there is that even if every mammal that was around at the beginning of mammals happening wasn't nocturnal, the ancestor was. So therefore, you kind of have this root in that.
Nocturnal root. Where did it come from? I think there is a graduate student thesis in here. Somebody who wants to do population dynamics of being eaten by dinosaurs versus having your sperm get hot.
Yes, I love it.
I wonder if you could do computer modeling and population dynamics of these two possible routes and determine which would be better.
Mm-hmm.
I don't know. I'm sure maybe. I'm sure there's a grad student out there who wants to have fun. We will see. We like having fun. We love having fun here on the show with science. And right now, we are going to take a break. It is time for that part in the show where we take a quick break. We are going to be coming back in just a little while, though, just a couple of minutes. We will be back with, oh my goodness, cool dinosaurs, more cool dinosaurs, not therapsids, but dinosaurs, and lots of brain stories. We'll be back in just a few with more This Week in Science.
Explain things you've heard more than.
Thank you for joining us for another episode of This Week in Science. We are so glad that you decided to spend your time learning about science and having some fun at the same time. We have our This Week in Science Blair's Animal Corner calendar available for pre-order at the moment. So if you want to get your hands on a 2020 calendar full of amazing art by Blair, she's made 12 animals from her art style of choice for this year, which is a stained glass look. The calendars are, she said, all the art is now done. So we are almost ready to start going to production. But we can't go to production if you don't order them, right? We don't want a whole backlog of things. So we do a bunch of pre-ordering every year. Go to TWIS.org, click on the frog. Click on the TWIS 2020 calendar image. Pre-order your 2020 calendar right now and get one for yourself. Maybe buy one for a friend or a loved one who needs a calendar for next year. You can always start learning. Get them in time for the holidays or get them in time for the new year. I cannot believe I am talking about the new year already. Oh, Blair's sharing her screen. I don't even know what to do with this right now. This is new technologies. Here's some pictures of some art. I haven't played with this yet. Woohoo! Some pretty art from Blair. As Blair is showing you these wonderful images of the art for the 2020 calendar, which looks amazing, by the way. I cannot wait to see this calendar produced, Blair. So much bright color. It's going to be wonderful. We also, at our website, you can also click on our Patreon link to support us in a monthly ongoing fashion, or you can click on our Zazzle link for other TWIS products. You can also click on the subscribe link to find Google, YouTube, or the Apple Store subscription links. Nice and easy for you for an ease of subscribing to This Week in Science if you have not subscribed yet. This Week in Science is listener supported right now, so all that you are able to do helps us do this show for you and for us to grow. We would love your help telling your friends about TWIS. Right? Tell your friends, bring your friends and family into the TWIS family, and we will all have science fun together and grow together. Maybe we can even do more together. And with that, oh, what am I supposed to say? What am I supposed to say? Thank you very much for your support. We really could not do it without you.
And we're back. You're listening to This Week in Science.
We are back. We're back with more This Week in Science. And now it is time for that segment of the show that we'd love to call This Week in What Has Science Done For Me Lately? Taking it up there. This week, I have a wonderful letter from Jacob Evans. Jacob wrote in to say, "Hi, TWIS crew. I have a contribution for What Has Science Done For Me Lately. I started collecting and enjoying houseplants around my home earlier this year. The spring and summer were different from usual in that anecdotally, my own seasonal allergies and those of my kids were dramatically reduced to the point of only being thought of a few days rather than weeks of puffy eyes and runny noses. Whether it's the plants filtering contaminants or the soil containing somehow beneficial microbes like the ones you guys discussed about people in rural environments in a May episode, I can't do more than speculate on. But what I can say is that through a variety of scientific pursuits, from botany to aviation to computers that run the nursery's inventory and ordering, I've been able to enjoy foliage from around the world without leaving my little corner. From the peace lily of Southeast Asia to the monstera of Central America to the prayer plant which moves its leaves daily following the sun from Brazil, all without leaving my Sacramento apartment. Thank you, science, for fueling my curiosity and my hobby." Thank you for sharing, Jacob. This is a wonderful, wonderful reminder that the plants around us can remind us about the science that makes our lives possible. I love those examples as well, these international examples of foliage, of flowers that have these different behaviors, these different looks, and they come from different areas of the world, and they have so much to teach us. Maybe they decontaminate the air, but we're not so sure about that. Maybe that's one of those stories.
Or maybe just having plants nearby make you less sensitive to other plants.
Maybe that's what it is. It's maybe like the you're like eating cat hair.
Yes. Sure. Yeah, just
habituate you. It'll just habituate you to the plants. Yeah, I don't know how well that works in a serious allergy situation. But Jacob, thank you for writing in. And everyone out there, remember, we need you to write in so that we can keep doing this segment of the show. What has science done for you lately? Give it a little thought. You don't have to write us a long letter, a short note, or a little tweet. Well, not a tweet because I don't really check the ones on Twitter. I can't remember all the different places. You have to send me an email, whatever little format you decide. An email's good. Kirsten, Kirsten, at thisweekinscience.com or facebook.com. Our Facebook page is This Week in Science. Leave us a message. Anyway, we want to keep doing this with something from you continuing into the future. Justin.
Oh, yes.
Tell me a story.
So we've been talking about the human brain as being this amazing organ. It is actually the all-star celebrity organ within human anatomy. It is housed in a shell of skull. It feeds on blood and sensory input, floating like a whale in an above-ground backyard swimming pool. It's 3 times the size of our nearest evolutionary ape cousin. And the human brain is not without its admirers. Among them, anthropologists at the University of Zurich, who in a recent study show that changes in the brain occurred independent of evolutionary rearrangements in the brain case. So we've been talking about this off and on for a while on the show about the development of the brain, skull sizes, how we have seen that they can actually grow and shrink. Brain sizes can sort of change over time, that it's not just a linear increasing in brain throughout hominin history and throughout even in apes. So this is finding that the relationship between brain and brain case, how they interacted during human evolution, is sort of not necessarily completely related to each other. The researchers were looking at brain and brain case relationship in our species versus great apes. They qualified spatial relationships between the cranial structures and the brain. This is Jose Luis Alatorre Warren, who used computed tomography, CT, and magnetic resonance imaging, MRI, data from humans and chimpanzees. They combined the CT and MRI data and was able to quantify the spatial relationships between brain structure, the convolutions and furrows. What is it? Gyri? What is this?
Yeah, the sulci and gyri.
Gyri and sulci on one hand versus the cranial structures and bony structures on the interior of the skull. Results show that the characteristic spatial relationship between brain and bone structures in humans are clearly distinct to those in chimpanzees. While the brain and its case continued to evolve side by side, they took different paths. For example, brain structures related to complex cognitive tasks such as language, social cognition, manual dexterity expanded significantly in human evolution. And this becomes visible as a shift from the neural and anatomical boundaries of the frontal lobe of the brain. This shift, however, did not affect the bony structures of the brain case. Instead, they're saying the changes in the brain case largely reflected the adaptations to walking upright on 2 legs. Bipedalism is more influential on the bony structure in the interior of the brain than the brain's development. Now, we can sort of then kind of argue whether or not the brain was following the new structure that it was finding itself in, right? The ability to sort of use space that may not have been there before or fill in. For example, here, the opening of the skull of the base for the spinal cord moved forward as we evolved to be bipedal to optimize balance of this bulky head at the top of the vertebrae column. But yeah, they say the changes to that brain case did not have an effect on the cerebral structures themselves. So this is a summary from Dr. Warren. The brain followed its own evolutionary path of neural innovation while freely floating in the brain case. The position and size of the brain case bones thus don't enable us to draw conclusions about evolutionary changes in the size or rearrangement of adjacent brain regions. And this sort of ties into then to the study that we covered some time ago about how bipedalism may have also been part of a mechanical pumping of the feet pushing blood to the brain case. You've got also then the positioning of the skull now for balance. You get the opening moving forward, which is allowing more blood flow. Because as we know, the brain is 3 times larger, but the blood flow is like is it 6.5 times more, or even greater than that. It's like maybe even a magnitude greater. The blood flow to the brain is incredibly larger than you see in any of the other apes. So it may be creating another argument for not just that mechanical action of pumping blood to the brain case, but the actual just needing to balance better while being bipedal opened up more space for arteries to move blood to the brain.
It's a chicken or the egg kind of argument all of a sudden. We kind of said, well, the brain must have changed, and of course the brain case changed along with it, and now this idea that it didn't. It's a really interesting thought to try and go through how it would have affected it over time. It's neat. I like this idea.
I do have to point out the chicken and the egg came first. There were eggs before there were chickens, so there was an egg, and then maybe a chicken came out of it. But there was always an egg
metaphorical chicken and the egg.
I hear what you say, but the answer is egg. Egg came first. There were eggs way before there were chickens.
It's a real Neanderthal boat situation, is what we're saying.
There we go.
Which came first? We don't know.
We're gonna switch it around from now on. There's no longer we can't have chicken or egg any longer. It's now a Neanderthal or boat.
Yeah.
And just to knock down one more, apples and oranges, very similar. Very similar. Almost indistinguishable when trying to show two things as having almost everything in common. We need to clean up our analogies, people. That's all I'm saying.
This has been Justin's Idiom Corner. Please continue.
Moving on from old humans and apes and brain evolution, I'm going to take us back to the idea of the cool dinosaurs, but it's still using an interesting technology that the computed tomography, CT tomography. And Blair, do you remember a little while back you reported the story about T-Rex and the odd space that they thought a muscle wrapped around, and they were trying to figure out whether this spot in the head was for the big jaws and the strength of the jaws, and they realized, it's a sinus for cooling down the brain and cooling down the blood in the head. Well, this study that was just published in the in Anatomical Record expands on the work that you reported on, and expands the work to several different groups of dinosaurs that the lead researcher at this in Ohio University's Heritage College of Osteopathic Medicine looked at. So Ruger Porter, he's assistant professor of anatomical instruction, lead author of the study. He said the brain and sense organs, like the eye, are very sensitive to temperature in animals today. We have these elaborate thermoregulatory strategies to protect these tissues by shuttling hot and cool blood around various networks of blood vessels. And we wanted to see if dinosaurs were doing the same thing. So they looked at long-necked sauropods, armored ankylosaurs, and the T-Rexes. They looked at several different groups and used the CT, the computed tomography imaging, to look at the insides of the skulls and figure out where the blood vessels went. And in looking at the different groups, what they pretty much found is that different dinosaurs had different kinds of cooling strategies depending on what their heads were like. So they didn't all have the very same strategy to cool their jets, so to speak.
So the ankylosaur, for example, I'm going to guess, did not do evaporative cooling through their brain because they are covered in armor.
We'll get to that in a second.
Okay.
Yeah. So first we have the long-necked Diplodocus, the sauropod dinosaurs. They had really long necks. Their heads were very far away from their bodies, and so the bodies might be hot, but their head could stay cooler. And a lot of them had blood vessels in the nose and mouth that actually did that shuttling of cooled blood, so that air evaporation in the mouth could have been used to cool blood in the whole nasal region, in the front of their face. And an interesting point by one of the researchers is brought up. You can imagine sauropods hanging out with their mouths open, using their open mouths to help them cool off on hot days. So maybe the sauropods, they're hanging out, they got their feet in the water, but their mouths are open like hot birds. Sometimes you see birds that are too hot and they keep their beaks open for that.
You know what this is doing? This is because of the story that Blair did earlier. It's making me realize that the head of most creatures is basically a scrotum for the brain.
There you go.
Yeah, there you go.
A way to get it away from the rest of the heat of the body, and to keep the brain cool. It's you know what? It's just a lucky bit of evolution that we don't have our brains and hanging from a fleshy sack.
I'm glad my brain is not hanging. Our brains are really important. Maybe that's the reason why. But yeah, thank goodness they're not just hanging.
Or it could be the other way around. We could have little scrotum skulls.
I mean, those were the models that didn't make it very far.
Yeah.
Natural selection. So now the sauropods, you can see they use their mouths and their nasal sinus for the cooling of the blood that would then go to the brain. The ankylosaurs, they have like the armored plating, but their necks are shorter and they're much closer to their body. But the ankylosaurs only emphasize the nose. I mean, I don't know that there's a necessary reason for that, but they say the body size might be a big factor. Smaller dinosaurs like the goat-sized Pachycephalosaurus stegosaurus had a balanced vascular pattern without a single cooling region that's overemphasized compared to other regions. And the researchers say that smaller dinosaurs didn't have an overheating problem like bigger dinosaurs did. So these big dinosaurs had to deal with cooling their brain down in this really interesting way. And what they call it is an unbalanced vascular pattern. And so this unbalanced vascular pattern allows these different thermal strategies to focus on one or another or multiple cooling regions. And so the sauropods had that mouth and nasal region. Ankylosaurs that they looked at seemed to just have the nasal region. And the theropods, like the T-Rex, they were saying that those were the different outlier, that they had the big air sinus in their snouts, and they had that evidence that you reported on, Blair, that this that air sinus actually had a bunch of blood vessels in it that created a different cooling area for these theropod dinosaurs. And so the fun here, though, is that we find that these dinosaurs, they all had different solutions to a similar problem. They had to cool their heads, and the heads, I guess, are not scrotums. Thanks for that now forever, Justin.
But there's in a Venn diagram, there's things in common. I understand what Justin's saying.
There are things in common for sure. So yeah, dinosaurs. They cooled their heads. Big dinosaurs. They were working. They had to do that. Justin, tell me another brainy story.
Well, it's handy that our brains are not just encased in a fleshy sack, perhaps, because brain trauma could be much more common if we didn't have this thick outer skull to protect it. But that thick outer skull that protects our brain also is kind of the source of damage to the brain. So in traumatic brain injuries, what's usually happen, or in the case of something like a concussion, is the brain case, the skull, stops very rapidly by encountering another object that doesn't want to be moved. And the brain continues in its floating whale in a backyard above ground pool to move over and hit the side. And this is the brain damage that takes place during a concussion. So it's been believed that the lasting effects that come from a brain injury like this is nerve damage to the brain is the lasting effects. And so things like we've talked about, they're considering things like a CBD that reduces inflammation and can help rebuild neural network activities might be beneficial. The research that was just done here by Cold Spring Harbor Laboratory professor Partha Mitra finds actually that they found much greater signs of blood vessel damage than nerve damage after performing post-mortem scans on injured brains. So what they're saying is, I'll just go quotey voice here. Nerve damage following traumatic brain injuries has been a majority point of view, and therapy as well as drug development has been targeted towards that. The idea that if the mechanism is actually different, therapeutic intervention may also be different. So they found considerable blood vessel damage surrounding lesions where the trauma left physical imprints on the brain. They used team used iron stain, which shows up blue in the presence of blood, and a myelin stain for the presence of nerve fiber fragments on the brain samples, and saw a significant amount of the iron-marked blood cells across the area where the lesion was located, indicating traumatic microbleeds caused by ruptures along the blood vessel across the brain. They did not observe any significant nerve damage from their stains. So in this, though, there is a little bit of a caveat that they point out that their setup was better designed for viewing the blood vessel damage than the nerve damage. So they might be slightly underreporting the nerve damage that was present because of the fidelity.
They're just not seeing it.
Mm-hmm.
Yeah, so that it's not ruling out that there isn't nerve damage, that's not a thing, that's not a problem, that's not an issue. They wholeheartedly admit in their paper that this is the way that this is designed. It was looking for contrast and didn't maybe pick up all of the nerve damage as well as it was picking up the vascular damage. However, showing that significant vascular damage and the microbleeding does then shift some of this focus towards figuring out how to perhaps stop bleeding in a brain right after an image as a priority over something that would be beneficial to preserving nerves. So reducing inflammation, yes, but also wanting to stop microbleeding in the brain, which different approach, different focus, but this is fantastic that they have they've delved into this and made this discovery. It seems like one of those things that, gosh, with all the sports medicine that we have, we should have be much further ahead in concussions than we are.
Ahead.
Didn't mean to pun it, but I actually have to blame the one source of concussions I think of more than any other. It's in the media. I mean, concussions come from everywhere. They can come in wartime battle situations. They can come on the sports field in football with helmets banging into each other. They can come between you and your partner, both reaching for a napkin that fell off a table at the same time. Like
cracking your heads together.
Yep. Places.
Mm-hmm.
But I tend to think of it in terms of football because it's now a real important aspect that's being focused on in injuries on the field. And it had been ignored for so long by professional sports that had they taken it seriously earlier, we'd probably be a lot further along, because sports medicine drives a lot of what becomes physical therapy in this country, because there's so much money and
Yeah.
They have resources for sure.
yeah, there's the resources there to focus heavily on it. But yeah, it seems as though, and it feels like the attitude of professional sports having changed and focused on concussions as a real critical thing to address to preserve their sport. I think is part of it too. Publicity is probably pushing a lot more research in this direction.
I'm sure you're right there. I'm sure it is pushing a lot of research, but it I hope what it does is it pushes treatments so that we have ways. I mean, the brain is virtually inaccessible unless you put a hole in the skull. It's really hard to get to help it. So the question is, what can you do after an injury to enable healing, to reduce the impacts of the inflammation, to reduce the impacts of those microbleeds that we're talking about? Like, how can this research, now that they're seeing these microbleeds are potentially a big issue, in addition to the nerve damage and inflammation, how can we put that into a bigger picture of treatment, therapy, healing? Yeah.
And funny you should say this. There's another story that I didn't bring, just because it sounds too much like a pretrial pharmaceutical thing. But there is a drug that is out in, I think it's a UK study. I'm not really bringing this story, but it is specifically it wasn't for concussions, but it was designed for people who were in like car accidents and that sort of thing. To reduce bleeding right after a traumatic brain injury, and it's showing some good signs of doing it. But interestingly,
that's cool.
It's working to stop the bleeding in the brain. Now, what isn't part of that story, part of also why I didn't bring this, is it's very preliminary. Also doesn't talk about long-term damage. It's talking about, okay, this is something you do to save somebody from internal bleeding in the brain right after an accident. As a concussion protocol, it may actually do more damage than good. We have no idea.
You don't know. Yeah.
But there is, like you said, ways of getting to the brain and stopping this without drilling the holes. That is something that is, from your mouth to yesterday's research, we're slightly behind the cutting edge, even at the cutting edge. Yeah.
Speaking of cutting edge, I think we all need to get some rest.
Okay, good night.
Nope, that's not what I mean.
Okay, sorry.
That's not what I mean. What I do mean is that it turns out from a new study that is in Nature this week that a particular compound, a signaling molecule in the brain called REST, R-E-S-T, may be responsible for how long you live. This new study found out that the amount of rest that's in your brain may influence the amount that your brain is excited or stimulated during your life. And that as you age, the amount of rest in your brain decreases, leading to more excitation and stimulation in the brain. And that can lead to earlier death. So basically, they looked at centenarians and the brains of centenarians. They looked at older individuals, looked at their brains, and found the older individuals had way more rest in their brains than younger individuals. Then they looked at fruit flies and they looked at mice that they genetically modified to not have rest, and they manipulated how much rest these model organisms had, and found that really the amount of rest influenced activity or activation of neurons in the brain, not activity in the brain, but activation of neurons in the brain, excitement versus inhibition. And the ones that got more rest lived longer. So now, what does this mean for us?
Okay.
Nothing really. We don't know.
So there's two things. It either means that a rested brain will allow for greater longevity. could also mean that overusing your brain will make you die young.
But that's so this is where it comes in when I'm trying to use the right words here, because it's not when I say activation or activity of it's not how much you're using your brain, because we know already that using your brain, that exercise, all these things that you would think of as activating, they're good for your brain and actually help to reduce dementia and help you live longer and healthier. So it's not about rest. It is about the level of stimulation that the neurons get at the level of the cell membrane and the ions that pass across the cell membrane. This rest molecule is involved in a chain of signaling pathways that that can influence the moderation of how much stimulation, how many ions can pass a membrane at any point in time. And so you might think of it, and I'll have my next story quickly after this is going to be one about epilepsy. And you might think of the epileptic brain. There are neurons in the epileptic brain in some regions that are always ready to be excited. And so they're hyper excited. And when they get over a certain threshold, then an epileptic seizure can take place because all of them get overexcited at the same time. But if their threshold level were brought down somehow, then the threshold of jumping to a seizure potentially wouldn't occur. There are thoughts like this along for migraine as well. And so what's interesting here is that this has to do with like the general health of the neurons, and that if you think of neurons are not just wires in your brain. They're living cells. Each neuron is a living cell that has metabolic processes going on inside of it. When these neurons do get stimulated to increase their activity, that means that they have to start making a bunch of things inside of themselves to send little molecules to other cells and so different functions start to happen. And so if that happens too much, that can potentially have a deleterious effect on the cells over time. But anyway, there's a lot of questions as to what in fact is going on here. We don't know much about this cascade that stems from rest at this point, other than it seems to be involved in longevity. People who live longer lives, their brains have more rest. But this signaling cascade does seem to be tied into certain behaviors, certain things that we've looked into, like calorie restriction, that also seem to affect longevity as well. So they all might be tied in together to the way that cell metabolism takes place and how these cells function. So anyway, maybe someday we'll all just be like, hey, I'm getting old. I need some rest. Yeah, but then moving to a really quick story here that was published in Science Translational Medicine. Some other researchers were looking at epileptic brains, researchers at Stanford University School of Medicine, and they found that this activity in neurons in epileptic brains in the areas that from which the seizures get started, that are seizure prone, there is a type of signal, an electrical buzz, so to speak, in the area. It's called a high frequency oscillation. And these high frequency oscillations can occur all the time, even when epilepsy patients are on medication. And they discovered that when they were looking at the electrical activity of the brain, they were able to see another kind of activity get disrupted by these high frequency oscillations. So they took patients and they stuck little receivers in their brains to record activity. And they then tried to get the patients to think about something, to remember something, to do something that took a determined cognitive effort that would create one specific kind of measurable brain pattern. And if within several hundred milliseconds, a high frequency oscillation happened in a before a seizure prone brain region started processing the information, the question that had been asked for them, the accuracy of the patients, or even just their ability to process and perform the cognitive task was completely disrupted. And so what they are thinking moving forward is, instead of looking at potential medications to treat epilepsy moving forward, maybe we can start looking at the brain activity moving forward. And they have actually moved forward in licensing a file for a provisional patent on a device, an implantable device that can be put in patients' brains to distinguish between the high frequency oscillations and regular oscillations and disrupt them, so that epilepsy patients would be able to continue functioning and not have to deal with any medication, which could be pretty cool. I mean, you don't necessarily want to put something in your brain, but at the same time, if it can disrupt some major seizures that are causing you life-disrupting trauma, then it could be cool. It could be cool. My final story for the show is, hey, scientists have made a vaccine for cats. But
no,
not
when you say for cats.
I mean it in multiple ways.
Okay.
A study published in the Journal of Allergy and Clinical Immunology from a group called HypoCat. They have published results on a vaccine that is given to cats for them to fight a naturally produced protein called FeLD1, so that they become less allergic to people who are allergic to cats.
Wait. Whoa. So this doesn't make the person who's allergic to cats less allergic to cats. This makes cats less allergic to people who are allergic to cats?
No, it
right.
makes them make less allergens, right?
There you go,
No.
Claire.
Okay, yes. It makes them make less allergens. My question is, might this be linked to something else that the cat actually needs? Just curious.
Apparently, in the study, it did not cause an issue with the cats, and it seemed to work. It doesn't desensitize the immune system of people allergic to cats. It goes the other way, trains the immune system of cats to go after FeLD1 so that they no longer produce the allergen anymore. The cats developed an immune response to the allergen. Booster shot kept antibody levels high. FeLD1 seemed to be neutralized in the lab, and the cats produced less of it in their saliva and their tears, which means they're putting less of it onto their beautiful fur, which would turn into then not become Danner, so cats would not be allergic. And when the cat samples were mixed with blood taken from human patients, there was less of an allergic reaction. So the vaccine did not appear to cause any side effects, or at least no serious or long-term side effects in the cat. But FeLD1 apparently has no critical function in cats that we have found so far.
Yeah, that we know of. Yeah.
Well,
that we know of.
Cats serve no critical function as it is.
This is not part of the story. But yeah, they are looking at potentially going ahead with this cat allergen vaccine, trying to get it to the market by 2022.
So it's an interesting sort of thing, though, because I suppose if you have a family member or something that's allergic to cats, so cat allergy is very
it's a big
serious
deal.
thing. It's a very serious thing. People can walk into a house where a cat lives and their tongue can swell up and they can no longer breathe and might need to go to a hospital. It can be so severe.
Or they can hang out with their friend who has a cat at home in a completely other location and start to have a response.
Yeah.
As well.
So, but what then I think is like, yes, I have this friend or family member who can never come over because they will die for my cat. So I'll give my cat this thing. Not get rid of the cat, right? But just give the cat a thing so they'll become less. But it's also like then somebody who's like, I've always been allergic to cats. The cats terrify me because they might kill me if I'm around one. But now finally there's something I can give a cat so then I can have a cat. No, you're not. Those people don't want cats. They have nothing.
There are
Some people do.
who are allergic to cats who have always wanted a cat. That is a
There
thing.
are. It is a thing. Don't tell me some people.
Just because they don't know better.
This is just you and
Okay.
your biases, Justin.
Yeah,
Well,
it's-
speaking of pets, I have a very silly story about pets, and specifically dog food and how owners measure out their dog kibble. This is a study that was done where they took 100 dog owners, asked them to use one of 3 common measuring devices to measure out kibble: a standard 2-cup scoop with markings, a 2-cup liquid measuring cup, and a 1-cup plastic dry food measuring cup. On average, people had underestimations, 48% under, to 152% overestimations on their food. It was all over the map. Of course, the worst one was trying to measure anything smaller than 2 cups with a 2-cup liquid measuring cup. Shocking. And the best option was to measure with a dry food measurement in the exact size you needed. But really, the gold standard would be to measure by weight, which makes sense. That's what we do at zoos for dietary reasons with our animals. We weigh out all of the dry food that we give to animals. This is exactly why, because there's variables when you use scoops. But ultimately, this is just a proof in the way measuring tools work, is what I'm seeing here.
I think this needs to be nominated for an Ig Nobel next year
Oh
for
my God.
discovering that people have no idea how to use measuring implements.
Yeah. Well, even just that certain measuring implements are good for certain things. A liquid measuring cup is good for measuring, liquid,
Liquid.
not kibble. Shocking. Anyway, so that was a very silly story. And then I just want to finish up with the
Whispering whales.
the teased whispering whales. Female Atlantic right whales whisper to their young to avoid eavesdropping predators. Yes, scientists suction cupped microphones to whales in the wild. And they actually found that in a typical right whale call that you could hear them from about 1 kilometer away. But when they had a young baby, their speech would only be audible at a range of around 100 meters or so. And they think that 10 times reduction in the range of that sound is to avoid them from being heard by predators.
Wow. Clever whales.
Mm-hmm.
That's clever, and they never would have known if they hadn't gotten up close and stuck a suction cup to the whales to
Yeah,
really
right.
hear them.
Suction cups on whales because science.
All right, Justin. Come in.
So this is a story about elite athletes. It says here, overall, elite athletes are at a decreased risk of death from cardiovascular problems. Makes sense, yes? However, there is a certain group of athletes that have a higher risk than the general population of cardiovascular problems, and those are American football linemen, which also makes sense. So if you've never watched the sport of football, I will only describe one aspect. And there's a line of guys on one side and a line of other guys on the other side who are going to smash into each other at the beginning of every play. And their average weight is probably over 300 pounds. These are big guys. These are really big humans, weight-wise and in height-wise in many cases. And so this is a study in JAMA Cardiology that is tying the increased risk of cardiovascular problems to rapid weight gain players undergo during early training. This is one of those strange athletic things where it actually is very beneficial to have more weight. It's essential in the role. When you are going to be an offensive or even a defensive lineman, outside of the physical training, learning a playbook, practicing, your main job is to eat, to gain weight, and to maintain that weight for your career. What's also interesting, anyway, in this study, they went through and looked how Division I college levels and above are putting on all of this weight to fill these roles in these athletic things, and they get things like high blood pressure, sleep apnea. They can also develop thick, stiff heart and arteries. So one of the things that they also discovered is that if you do aerobic exercise, you can reduce a number of the complications that are associated with this risk. So as long as, and they're of course saying that they can apply this then to people who are not athletes, but simply have larger weight to them than the average population and might be at more risk for cardiovascular disease than the general population. It is one thing that it's also interesting is this is, if any one of us is like, okay, so in order to do next week's episode of TWIS properly, we all need to gain 40 pounds apiece.
In a week?
Yeah. Or, by the end of the year, we all need to put on 40 pounds. Okay, give us some time. Then we have Thanksgiving and Christmas. It won't be that hard. It's a pretty dramatic shift. And one of the things that when you look at these players, you might just assume these are naturally big people. It's great that a 300-pound athletic person has a role in an athletic event, because in a lot of sports that, being 300 plus pounds might not be beneficial. Not good for the high jump, not good for, running the bases maybe. There's a lot of things where this wouldn't. But this is part of a training regimen that gets a lot of these guys to this weight. One of my favorites is a center for the Indianapolis Colts who retired. His name was Jeff Saturday. So, he's a center. He's right in the middle of the line of these big guys. Always a really big guy for his like a year after he retired. He's like my size. Like he just didn't have to eat as his job anymore. It wasn't required for him. The weight just vanished. He wasn't genetically predisposed. This was actually a physical training thing. So one of the things that this study is revealing is for those people to maintain health while they're going through this professional decision to maintain these really high body weights is to spend a certain amount of time doing aerobic activity to sort of counteract. And of course, then you can translate to the general population of, even if this isn't about you aren't able to lose the weight, or this isn't the focus of the exercise as a weight loss thing. Mm-hmm. Maintaining high aerobic activity, exercising your heart and your cardiovascular system will reduce the ill effects that are normally associated with that greater weight.
This makes sense too, because sumo wrestlers, they are known to have no cardiovascular issues. Well, because they're putting in 7,000 calories a day. Sometimes these sumo wrestlers have to be like 400 pounds at least, and they're massive, but they train constantly. They have a very heavy training regimen, and it's constant. It's just the way that they live their lives. And apparently, when I was just looking at another article while you were talking about that, they after they retire, have to cut back their eating because they stop their training regimen. And if they keep eating at that rate, they die at a 10% higher rate than the rest of the population of cardiovascular issues. It's like everything catches up with them all of a sudden if they don't keep up with the exercise. So I think what you're saying here is exactly right. And now they're putting it into this new situation of football players, or we can, like you said, put it into everybody's life. If you're going to eat, You got to balance it out.
Just generally, take care of your heart. Move. That's what this is about.
Yeah, and they blame the sumo stuff on its visceral fat, so the fat that wraps around your organs, as opposed to the fat that just gets put underneath your skin. There's different kinds of fat, and if you have lots of the visceral fat, which can, that's the stuff that causes the hardening of the arteries and a lot of the other issues. Yeah. Pretty cool. Pretty cool. Work it out, everybody. We've come to the end of another episode, haven't we?
We did it.
Did we do it? We did it. We did it. We're at another episode. Thank you, everyone, for joining us. Thank you for sticking with us through a romp of science. I would love to give shout outs to View People before we go. Shout outs to Gord McLeod for helping to manage our chat room. Thank you for that. Identity 4, thank you for recording the audio of our program. Thank you to Fada for helping in social media, show descriptions, and so many other ways over on that YouTube chat room for sure. And I would love to give a shout out. Fada told me that Wall Street Tech on YouTube gave us a donation over there on YouTube. Thank you for that. That was amazing, Wall Street Tech. Really appreciated. And now I would love to thank our Patreon sponsors. Thank you to Paul Disney, Ed Dyer, Andrew Swanson, Craig Landon, Andy Groh, Ed, Stu Pollock, Philip Shane, Ken Hayes, Harrison Prather, Charlene Henry, Joshua Fury, Steve DeBell, Alex Wilson, Tony Steele, Richard Porter, Mark Massaros, Jack Matthew Litwin, Jason Roberts, Bill K, Bob Calder, Patrick Cohn, Eric Knapp, Richard, Brian Condren, Dave Neighbord, Howard Tan, Gome K, Donald Mundis, Sarah Forfar, Dan K, Matt Bass, Darwin Hannon, Patrick Pecoraro, Ben Bignell, Jean Tellier, John Gridley, Corinne Benton, Adam LaJoy, Sarah Chavez, Rodney Lewis, Tiffany Boyd, John Bertram, Mountain Sloth, Seth O'Gradney, Stefan Alberon, John Ratnaswamy, Dave Friedel, Daryl Myshak, Paul Ronovich, Sue Doster, Dave Wilkinson, Noodles, Kevin Reardon, Christoph Zuknarek, Ashish Pants, Ulysses Adkins, Artyom, Rick Ramus, Paul, John McKee, Jason Olds, Brian Carrington, Christopher Dreyer, Lisa Slazuski, Jim Drapeau, Greg Riley, Sean Lamb, Steve Leisman, Kurt Larson, Rudy Garcia, Marjorie, Gary S., Robert, Greg Briggs, Brenda Minish, Christopher Rappin, Flying Out, Aaron Luthen, Matt Sutter, Mark Hessenflow, Kevin Parachan, Byron Lee, and E.O. Thank you for all of your support on Patreon. You are interested in supporting us, you can find information at the Patreon link at TWIS.org or go directly to patreon.com/thisweekinscience. Also, remember, you can help us out simply by telling your friends about TWIS. On next week's show, we will be joined by computer scientist Melanie Mitchell to discuss her book, Artificial Intelligence, A Guide for Thinking Humans. Once again, we're going to be broadcasting live online at 8 p.m. Pacific time, Wednesday evening. TWIS.org/live is where you can find us, or on YouTube or Facebook. Watch live, join our chat rooms. Don't worry if you can't make it, though. Past episodes will always be available at YouTube or TWIS.org.
That's right. And if you'd like information on anything you may have heard here today, show notes are available on our website. That's at www.twis.org. That's TWIS.org, where you can also make comments and start conversations with the hosts and other listeners.
Or you can contact us directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twis.org. Just be sure to put TWIS, TWIS, somewhere in the subject line. Otherwise, what will happen to your email?
Your email will be spam filtered into oblivion.
You can also hit us up on the Twitter where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you'd like us to cover or address, a suggestion for an interview, a haiku that comes to you in the night, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple topple the ground. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just yet understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say, and if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 Got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. But how can I ever see the changes I seek when I can only set up shop 1 hour a week? This Week in Science is coming your way. You better just listen to what we say, and if you've learned anything from the words that we've said, then please just remember it's all in your head. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.